Abhijat. I am a principal PM in Microsoft. And today in this session, we'll talk about how you can isolate your Win32 apps and get some benefits out of it. But before we get into the details, this is just a quick text on this session, and we have to show it. So I'm sure you would have seen this in the other sessions also. So we'll pause here and let you read. And then let me introduce you to our speakers today. And we have a few folks as well as SME on the call as well with us. So I'll start with Sumit. Sumit, he's a principal product manager in Microsoft, and he has experiences in designing Windows security products as well as cloud security. He has a total of about 15 years of experience in the IT industry developing solutions across different verticals. The next is Salah, who's our principal architect. And yeah, Salah. Salah has over 20 years of experience in designing security products ranging from networking to isolation. In fact, he was one of the key developers in creation of the app containers, which today are present and provide security benefits in the UWP apps. And then we have Dylan, who's here, and he's our engineering manager. Again, about 17 years of experience across different security verticals. Dylan was one of the key developers on Windows Phone as well, and now he's playing with different isolation technologies to produce security benefits in the Windows platform. And then we have Rohit, who's on the call. Can we see you, Rohit? There you go. Yeah, and Rohit is our SME from privacy vertical, about 20 years of experience total, and he brings in the expertise of privacy as well as security in the Windows platform. And last but not the least, I am your moderator for today. I have about 20 years of experience in the industry, worked across different big and small companies, and now leading some of the security products in the Windows platform. So with that, what we are going to cover today is, and we are not going to bore you because with a lot of slides, because this is a discussion session, so we'll keep it open. But to set the context and to introduce you to the topic, as well as talk about an important call to action, what's going to happen this week with this particular technology, we have put a few slides. So we'll go through a few semantics of those, and we'll introduce you to the topic at hand. With that, I'll pass it on to Sumit, who's going to talk real quick about the technology. Sumit.
Thank you. Hi, everybody. So thank you so much for attending a 5 p.m. session. And I love the enthusiasm. But of course, this is just part of it. I just want to start by asking how many of you have heard about Win32 app isolation? Like outside this session, has anyone eavesdropped on you? Hey, this is coming, guys. One of the coolest things. Have you? Just show of hands. OK. So that's sad, but good. That means things don't get out usually. So let me just quickly give you an overview, and then we'll get to. So for a moment, imagine the right side doesn't exist. This doesn't exist. And those of you on Teams, I don't know if you can see me, just look at the left side for a moment. So we have this idea of, I won't say an idea, the approach rather, which is, of course, it's working today. But the approach is we want to combine two sets of approaches when you secure your application. The first is what we call as preventive or blocking things that we don't trust. But that's not enough, because we know that even with the best blocking strategies, you have to account for incidences where there's a compromise. So smart app control is designed for making sure that any application that's not trusted or is not wanted is blocked. And I'm giving you a very super high level explanation of that, because this session is not about smart app control, but to kind of give you the point here. Now, if you take that and you combine that, okay, what if I get compromised? So what if I get compromised with everything, every guardrail out there? What is the extent to which that malware can then go and impact my customers? And it is more important for application developers and customers, because people you're selling to, what's the value proposition for them? Like your app, if it is isolated, you're guaranteeing to a large degree that yes, you have all these guardrails, all these controls, but then in the worst case situation that you do get compromised. And the question is, why would you get compromised? It's not because you are writing apps deliberately that are vulnerable. But the point being, classic example everybody gives is the log4j attack, right? I mean, you're using third-party libraries, and you're probably using a cascading bunch of them. Maybe you're using a library that is in turn using another library, which you have no control on. So vulnerabilities exist. This is the way of life. We have all accepted it. 0 days exist. We've accepted it. So we want to combine both preventive and containment strategies, and that's why we, have this product, which we haven't given a formal name yet because we are just launching the public preview of it. Of course, it was supposed to be said later, but I couldn't resist. But anyways, so that's one benefit of it. The second benefit is privacy. How many have heard about GDPR privacy? Your apps need to comply. Huge, right? So with privacy, guaranteeing privacy, one of the fundamental building blocks for that is security. I mean, security is the basis of which how you can guarantee privacy. Of course, I don't want to get into a debate here, but that's kind of the general theme here. So why is that? Because when you contain these applications, when you isolate them, you sandbox them, the different names for it, the key difference is the app is no longer running at the same privilege as the user. So if I had to explain it to a 5-year-old, or well, not 5-year-old, that's probably not fair, but maybe a 5th grader, my daughter is in 5th grade, so I try to explain things to her. Think of it this way, that if your application is running as you, then it can pretty much do anything that you can do without even telling you, right? So if you can go and change the camera setting, what's preventing the application from doing it? Because it's running as you. So the point is, we don't want the application to run as you. We want the application to be running at a lower privilege than you, so we can contain and we can make sure that it tells you before it does things. Again, this is a pitch to a 5th grader, but then in a sense, it's true. So the way we're going to do this is, we want to go over these slides with you quickly so that you kind of get a sense of what we're building. And then, we'll open it up for questions. And then when you get to questions, we can get back to these slides again. Now, I just wanted to talk about a few things here. Like with any product that we build, security, one of the big challenges of building a security product is you can't really talk about fancy UI. You want that product to work as is, and security should be hidden, and it should happen. So the reason I'm bringing that up is we have 3 key objectives in building this experience for developers. It's not just building security and compromising on the usability. So of course, the first objective is to make sure that you're securing your application, but then you have other stakeholders that you're building the application for. The first stakeholder is you. We are always told to advocate for ourselves. And so as developers, you should be advocating for yourselves. And we, of course, advocate for developers. So how do we make it easier for you to build an application which you've built with the assumption that it has free access to all the APIs? Now we're asking you to contain it. How do you make sure that if you have an existing application, we make it easier for you to then isolate it? And I'm going to use the word isolate and sandbox because technically they are same if we don't get into a geek land of debate. But then being geeks, I just hold that mentally, think of them as equivalent. So one of the, again, the second thing for us, like I was mentioning, is to build tooling so we are able to get an existing application, time to market. We reduce the time to market for that. And Salah is going to talk about some of that. Then the third one, which is equally important, is the end user experience. See, one of the easiest way you could call something secure is by starting to throw consent prompts for the user to every decision, you're offloading it to the user. That's not security, because then the user doesn't know what to say yes, what to say no, especially if you start throwing cryptic prompts and say, hey, this file wants to access this .NET library and this blah, 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 blah. Do you accept? I mean, the user is, oh, sure, I don't know what the hell you're asking me to do. So one of the key things for us is to make sure that while we build security, we also want to have a fine balance where we ask consent from the user, where we are intelligently and contextually able to apply that in the application, excuse me, in our security, as part of our security instrumentation. So these are the three important parts. If we had just done the first, and if we don't focus on developer experience or the end user experience, you could build the most secure product, but nobody uses it. There's no point to that, right? So anyways, I just wanted to start with that. And these are the things we would encourage you to, if you have questions, these three are the key parts. And now I'm going to hand it off to Salah, who's going to get, I'm sorry, Salah, I didn't want to steal your thunder. Thank you.
Hi, so, hello? Okay. Hi, so yeah, I'm Salah. Let me get started. So thanks, Sumit. So if we actually look at how this is built, now the reason I'm doing this first is because other things won't make sense if we don't do them afterwards. So if we do them beforehand. So if we have a look over here, the way that this is constructed is we're still using app containers as the key mechanism for actually isolating. So don't get worried. This is not UWP. This is app containers, which is the technology that we built before UWP was built. It was basically the isolation technology in Windows. So this provides us with isolation between processes, between like lower IL, basically between app container process and then other processes, and also like higher IL like medium, and then also between other apps also running the same thing. Then we use Helium silos. And the reason for the Helium silos is principally compatibility. By doing this, and it uses MSIX, both if you package apps or also unpackage, where you say, okay, this is going to run, you do an install, and at the end you just register an MSIX that identifies the application. So why is that important? Well, as Sumit mentioned earlier, in order to do privacy, we also have to know which application is actually asking for something. So by leveraging MSIX, we actually have an app identity that we can use. Now, within the Helium silo, we have file system and we have registry virtualization. Now, this is not a sandbox. This is not a VM. It's just literally virtualization at the file system level and at the registry level. And also this simplifies installation and uninstallation. So for example, if you install an MSIX and you want to go and remove it, it's very simple to clean everything up. It also helps it to show up, for example, in the settings, so you can see the app settings and manage that. And if you have a look in the right-hand side, you can see that you have an isolated Win32 process. Inside there, we actually have access to brokered data, and that's the other thing we use is brokering. So for example, we actually have a brokering file system which allows existing APIs to work. So let's say, for example, you go and use iFile, like the file dialog, to show a prompt and say you want to open a file or save to a file. That basically talks to a mini filter once a decision is made. So that runs in a broker process, which runs as a user. Once a decision is made on what file wants to be opened, what file wants to get written to or saved, that goes and tells the driver, hey, this application is allowed access to this file. And what will happen then is once the call returns to the calling app, when it makes the call to create file or open file, that'll automatically succeed because that actually happens under the covers, basically inside the mini filter. And this actually manages access for user files and directories per app. So each app has its own context. And this works for SMB shares as well. It works for any file on the system. And what this basically allows us to do is to make it seamlessly work without actually impacting the user. Now, we also want to reduce the developer effort. If you've ever tried using app containers, you know they have capabilities, and capabilities are one way of granting access to certain things. And the way that we reduce the developer effort in this instance is we have a capability profiler. So what that does is it actually goes ahead and you go and, for example, package your app and then you run it within the profiler. And this will go in and you'll work through it. For example, it's basically like instrumenting the app, open it up, open files, do whatever you want it to do, depending on what the app is. And that'll basically run in learning mode, and it's going to capture everything that you're doing. And then when you save that, we then have the application profiler will actually go and pass the event log to see what actually happened. It'll generate the necessary capabilities. So for example, if you tried and went to add a systray icon, it'll know, okay, you wanted to add a systray icon. If you want to do, for example, a shell context menu, so you right click on the file in the Explorer and you say open with, it'll know, okay, you're doing that, I need to add that capability as well. So all of those are managed. If you print as well, it'll say, okay, you need the print capability. So all of those are automatically determined. And then what happens is that actually produces the capabilities and say, include these in your manifest. And I know at some point they're going to actually add it to the manifest. I don't know if we've done that yet or not, but it's automatic. It is automatic. Okay, so it'll actually automatically update your manifest with the required capabilities. Now, as we mentioned, we also want a seamless user experience, and Win32 apps can do a lot of things today. So as I mentioned, for example, we support things like file type extensions, so for associations. So for example, if you have a particular file associated with your application, if you double click that file, it automatically gets brokered so that you don't have to go now and the user's not getting prompted or anything like that. Same thing, for example, if you're doing a shell extension, you right click and you say open with, that manages brokering as well. Even drag and drop, which is the next one, is the same thing. You drag and drop a file, brokering happens out of the cover, and the brokering is persistent. The user can remove it later, but it's persistent. And then we also have things like systray icons as well. So for example, if you have like an app that wants to have something in the systray, you basically just call the same APIs as before. There's no code change. In fact, for the majority of this, there's very, very little code change, unless there's certain instances where there are interesting things. But in general, we've been testing apps for months now that are just completely unmodified and simply just packaged this way. So if we actually look, for example, for data and privacy, as you mentioned, the app is running isolated. Now we do allow prompting for the file system, but that's only if your app actually has to do that. So let's say, for example, you profile an app and the app doesn't have to access anything outside, for example, its own files or anything like that. What only goes through the file dialog or drag and drop or shell extensions. It will basically not have the capability, so a user will never get prompted for the app to access the file system. But in the case where we do have that, we basically have, obviously it'll prompt and say, do you want to allow access, yes or no? And obviously that's something we want to limit if possible, but there are obviously instances where we can't. And basically there's also other instances as well. So for example, file system virtualization makes sure that there are certain portions of the file system that the app needs access to. It'll never get prompted for that. And also, registry virtualization as well allows us to essentially do certain things. So for example, the way it works is that, let's say you run an app, it runs in the Helium silo and it has the registry virtualization by default. Every time you try and access a key, if the app, for example, if that particular token, like the app container token, has access, like read access to the key, then we automatically enable write access as well in the virtualized key. So the keys are virtualized and any writes that it does are local to itself. So it can change whatever it wants inside the application, and it'll continue to see those values updated, but other applications in the system will not be affected. If there's no access at all, so let's say, for example, you have a case where it tries to access a key it doesn't have access to, we wipe out all the values, and we actually create a new key, which is also virtual, clear all the values, and there's no data there that's leaked either, but the application still functions as normal.
So Salah, let's pause here for a second.
Sure.
And this is great, by the way. During your notes, you also mentioned that this is not making an application into a UWP application. So how is this technology different from what we did to secure the UWP apps?
So the thing is, the UWP apps are different in many ways. One is that obviously they're still running with the same token, but there's many APIs they couldn't actually access, for example, and the reason was those are explicitly blocked through things you had to use, for example, like load library from package and things like that. So you actually explicitly blocked. And part of that is because, and one of the reasons we need the registry virtualization is actually because when you're running a Windows app, you don't actually know what's happening under the covers, right? You can load some library, some DLL, and just doesn't access to something, and now you have a problem because the API is failing and you don't understand why. And that's essentially why we're leveraging virtualization. So this is a regular Win32 app, simply just running within this container as itself. I mean, as I mentioned, we've had many apps running for months now with virtually no code changes or no code. In fact, most of them are no code changes at all.
So wait a second. I think that's a very important point here, and I would like others to chime in as well if they think. It looks like, does the developer has to make any changes to their existing applications to make use of this technology?
Not generally. The only time we found is if you, for example, want to use like something from program data and you don't want to prompt. So for example, you had a directory under program data, and we actually have a way to do that. So it'd be like a code change to say, okay, when you create your directory there, just append a particular thing which identifies your app, and we can do it without prompting. But that's about the only thing that we've seen so far that required code changes.
Great.
Yes.
Yeah.
What about since Win32? What about things with shared memory, like name elements, stuff like that, which other application could use?
I mean, you're okay. Sorry. So the question is, let me see if I got it right as well. So the question is things like how do you access things like shared memory that the other application could use?
The application creates an event where
So the way that works is, and that's worked the same way since we did app containers, is that we do have namespace isolation. So for example, it'd be under what is it, the object namespace for that particular application. The other app can open it directly, essentially, even if it's running even if it's a MediumIL app or anything else. There's actually underneath the normal base name objects, there's an app container named objects. Symbolic link, and as long as you know the target you're talking to, you can actually do that. So if you know, for example, what the SID is, or you can have access to the token, you can actually call, I think it's get app container named object path, and it'll actually give you the path back, which is the API you call, and then you can open it from there. Obviously, it has to be the right permissions for it to access it. If it's a MediumIL app or regular app, it can do it just fine.
Actually, there is a, sorry, was there? Yeah, I think there is a similar question in the chat also, and let me read that. Gregory is asking, are IPC mechanisms like named pipes also supported?
Yes, in fact, so IPC mechanisms today, are you talking about creating them or using them?
Not specifically, but okay. I think probably for using them.
Okay, so yes, you can connect the name pipes that exist, but also when you create a name pipe. So for example, one of the challenges we had to overcome is that when you create a name pipe today and you don't specify the local, which is what's required for being in an app container, it fails. So the broken filter driver actually intercepts those creates and reroutes them automatically, and it knows, okay, this one has gone here. This is what the path is. So that'll actually automatically work. And if you're using it from outside, you have to essentially use the same path that you would use otherwise. So there's already a way, also using get app container named objects, to actually figure out where that name pipe would live. But those work seamlessly under the covers. So for example, I think I was testing one app which actually used name pipes for, it had multiple processes using name pipes for inter-process communication, and that just works seamlessly. So it has no idea it's running inside this context.
Awesome. Any other question?
So MSIX does not, the question is, for example, if you install Notepad++, is it going to ask you to essentially elevate to install it? No, so the thing is that MSIX does not require any admin permissions. You just simply run it, it'll automatically and do the installation. You can do a per user or a system-wide installation. And actually we've been testing with Notepad++ as well, also without any code changes. So that basically is already supported with MSIX. That's one of the reasons why MSIX is useful, is it doesn't actually require you to elevate, because it has a service that manages all of the elevator-related tasks. So you never actually have to elevate the installation itself.
Yeah, so I think that's a very good point what you raised, because many a times we don't even know these different applications which we are using, how many times are they asking for the admin privileges. Because if you're logged in with local administrator rights, then many a times these applications will ask the privilege, the user will have it, and it will get granted. You would not even know. But with MSIX technology, you would be actually deprivileging the application, and then you can ask your app developers, why do you need certain privilege? Because the app will not work, right, in that case. So that's a very good point.
Any other ones?
I think there is one more follow-up question from Gregory, and he's asking how much different is the new app isolation from the isolation provided for Sentinel apps?
So Sentinel is really running as full trust. So it's running as a MediumIL, which means it's running as a user. So it can do anything that the user can do, which includes getting access to networking credentials, or essentially doing anything it wants to any files the user owns, or anything like that. So Sentinel is actually running essentially without any boundary other than the user, whereas this is running within a isolation boundary that prevents it from doing things that would otherwise happen.
Yep. So that makes me ask another question, Salah. You also mentioned, I think Sumit mentioned that running inside Win32 app isolation primitives is going to limit the damage which probably a compromised app can do. So how does the damage gets limited? Can you throw some light on that?
The reason is because we're basically isolating everything, the application only has access to things that have been explicitly granted access to. So for example, if it has access to the camera, then it can still access the camera, but if it doesn't have camera access, it'll never get access to the camera or the microphone or location. Similarly, the files that it has access to is also limited in essentially what's been brokered, and also it has no way to determine what's been brokered. So for example, and in most cases, we don't do brokering on directories. We do brokering. We can do directories, but in most cases, it's in individual files. So even in that case, it can't figure out what else is there and infect those. So ransomware, for example, is very limited in what it can do. It'll firstly have difficulty figuring out what files the application has access to because there's no way to enumerate that. You have to be running at least as a user to enumerate that. And therefore, it's actually very, very limited in what it can do. It can't really break out of that. It can't do things like loopback network traffic. It can't do. Yeah, I mean, it can do DL injections in itself, but it can't do any code injection in anything else. So it's really limited in essentially what it can do, and that's the whole goal behind it, is to say we want we don't want developers to rewrite their apps. They want to basically have them to basically take the apps they have today and continue to use them. But at the same time, this gives developers a competitive advantage because now they can say, okay, fine, my app is running contained, so even if something happens, I'm not going to affect the whole system. Right, and the same thing for us. There's also benefit for consumers because consumers now know, okay, I'm installing these apps, and something happened, but I'm still safe. I didn't get affected. So even if it got compromised, even if there was a vulnerability in some third-party library or some old library that hasn't been updated, which we know there are. I mean, we've even had them in I've seen in other places as well, where basically that you have a library that's been there forever. There's no code, no one maintaining it. You do require it, but you can't do anything to actually stop an attack on it.
Can I just add one thing there?
Yeah, sure.
One more point, Salah. So I think with security, like I mentioned before, there are certain capabilities that probably grant you a large coverage of access. So like I said, for us, it's important to also look at usability of the app, the compatibility. So in public preview, we are launching, we're not basically giving any prescriptive guidance on, hey, don't use these capabilities, but that's something we want to eventually enforce down the line. And the reason being, we want to have this fine balance of making sure that the experience to the end user is not disrupted. We are kind of getting on the incline there with slowly tuning the knobs for security. And also, one of the things for us to consider is depending on the environment. So the application, if it's running in enterprise in a very sensitive environment, they would need knobs that are very different for an application that's running on my grandma's machine, for instance. So I think just something I just wanted to add on, like, so default would be probably let the app run in grandma's machine, but then also provide the controls. So if you're running it in a more sensitive environment, you have those knobs.
Yep, great. There is one question in the chat about the availability of this technology, which we are going to come back to in a second. But before that, I want to ask audience if there is any other question. Go ahead, please. Yeah.
Yeah, so the question is the MIDI filter is already there. So the virtualization is actually done with existing MSIX or Helium virtualization. So it's bind filter, and I think it's WCI NFS or something like that. The driver, the MIDI filter that does the brokering is not doing any virtualization. But basically what happens is when you, for example, go and launch the application, that actually goes and creates the container, which is I guess the silo, which is really just a very enhanced job object. And within there, it actually sets up what is virtualized. For example, here's the container ID, and here's the file system that's virtualized, and here's the registry that's virtualized. The other driver that we have, which is the mini filter, which is the brokering file system mini filter, has been there. I think it's already in
Windows 11.
It's already in Windows 11.
Yeah. So. Yeah, I can answer. So it's this technology, and this is how we build most of our technologies to work with the next version of the Windows or the upcoming version of the Windows. Now, this technology has been in preview with some selective customers and ISVs of ours since last almost a year. So I think that's what Salah was saying. The mini filter driver has been present in some of the Windows 11 Insiders build, which you may have already tried in the past. But I would say the technology is not generally available. Like it's present there, but we wouldn't recommend for the production use because we have been in a preview. And we'll be just talking about now what's next after this. So going forward, we'll be launching a public preview of this technology. And as we speak, we'll be making live the documentation as well within this week. But yeah, but coming back to now your question very specifically, this will be GA'd in one of the future version of Windows, but you can start using it right now. You can start instrumenting your applications with this technology right now. And the whole idea there is that you can give us a feedback if there is a capability which we have missed, if there is a issue or there is a bug, then we'll fix that and we'll make this generally available to all of you so that you can start developing production applications. So it's a preemptive way of preparing you with the technology as well as the tooling, right? If there is a gap in the tooling which you need to prep your application, then we have to give that to you as well, right? Sorry, was there a hand there?
Yeah, I was going to ask.
Go ahead.
So say that one of these isolated apps does like a create process call. Like what happens to the child process? Is it in the container with it, or does the operating system take over? And if it's an isolated app, it also needs its own container. Like how does that story work?
Okay, so the question is, if you call create process from one of these processes, what is the net result? It depends, but basically, generally it'll just launch in the same container. It'll run in the same context. So that way, and there's a reason why you'd want that. So, for example, if you have an application that is almost like a platform for other applications, or you want to run other things that depend on you, you want it to have access. So, let's say, for example, you're using like VS Code or some developer IDE inside the isolated container, and you want to run Git or you want to build something that should also be running within the same container. Otherwise, it won't have access to all the files you have access to and things like that.
So I think that brings us to another question. Maybe I think we have been thinking about it. As a developer, what kind of tooling is available to me so that I understand everything what my application is doing? Let's say it's creating a child process. Let's say it's touching a file system or a network share. Is there a tool, Salah, available with this technology through which I can understand and then I can put the right isolation primitives around it?
That's actually what the application capability profiler does. Is it actually goes through and figures out what is the application accessing, what is it using, and even goes as far as giving call stacks. So let's say, for example, you hit some weird issue, we can either you can figure out from yourself what's happening in the call stack, or it can get sent to us, and we can figure out, oh, maybe we need to add a new capability, or we need to handle something differently, or maybe there's a different API. But so far, we haven't encountered anything that required that.
Yeah. See, this is exactly what I was talking about. So in public preview, when you start using these tools, this app profiler tool, then you may discover some things, right, which we may have missed, or maybe it's not telling you, and then we have to fix that and then make it ready for the general availability. So I think it's a good thing to pause here, and then should we want to come back to the slides and talk about the next steps here? So like I said, this technology has been in preview for last 1 year, and we understand that we are going to touch a very big surface here. Can be used by every application developer on Windows which uses Win32 technologies, right? So we have been trying it out with a set of customers, and you see some testimonials here where they have used it. You see some of the enterprise houses here, some of the app developers, the software like Sumit was saying, essentially you write lines of code and there could be vulnerabilities. There is a video software out there which got attacked again and again, and they got very serious benefits from this. So the next steps now. So like I said, we are actually launching the public preview of this. So far we have been trying out this technology with a handful of customers of ours, app developers as well as enterprises. Now with the public preview, this technology is available to everyone, for all the application developers, whoever put their application on Windows using Win32 primitives. The technology is made available in the form of public preview, and the documentation is live as we speak. It's available on the GitHub. So please feel free to go there, download these tools. There are some code samples, and give us a feedback. There is anything you want to add, Dylan? Salah?
Well, thank you very much.
Yep, and let me quickly look at if there is any other question in the chat. So yeah, I think Kyle asked when will we see these changes implemented. So we are launching the public preview, like I said, and as I mentioned, this is available in the current insiders of Windows 11 with the intention of making these available and generally available in the next version of the Windows. Yep. Go ahead, Dylan.
There was an earlier question about the OS builds that correspond to this, because there's obviously in the GitHub we have our tooling, so you'll find that there, but we have information about which insider builds you can use that pair with that have this functionality enabled.
Great. Anyone on the meeting chat who have joined us remotely, if you want to ask any question to the speakers today, feel free to raise hand and unmute yourself and you can ask the question. I guess not. Or if you don't want to ask, feel free to put it into the chat. We'll be around for a couple of more minutes here as well. And Rohit, who's our SME, I want to remind you again, he's a privacy expert. He's a product manager who focuses on privacy part of Windows. He's also available today remotely. So if there is anything we want to ask with respect to applications as well as intersection with the privacy part, we can feel free to ask those questions as well.
It's late, I know. I mean, it's like.
Yeah, I think we are the one who are holding you from your dinner.
I just want to get a sense from, I think we probably, not to hold you up for evening, what is your take on this? Like, anything that you would like us to kind of focus on, things that you've struggled with in the past with sandboxing and isolation? Anything top of mind for you that?
I can say that I am a driver developer, so I am interested in the virtualization and the part because there's kernel isolation, right now, and running drivers in kernel isolation has created some problems with some access to some hardware. So since
Drive.
Interesting.
Drivers that.
I was looking at
Yep.
I was really interesting, and actually,
Yeah.
That's my dedication.
Yeah.
There is one question on the chat, pretty interesting, and Luke is asking, will the operating system handle apps which don't opt into app isolation? So in other words, how will the OS readjust itself for any application which is not opted into Win32 app isolation?
Take that. I think our primary focus here is, I was just giving the more of the product answer here. See, like I said, we want the experience to be seamless. So developers, if they're not involved, I mean, you could essentially package the app, but then our focus right now for public preview is to do this in partnership with developers. Like Salah, probably you can add on to this if you have any.
Yeah, I can also add a little bit. So see, going forward, our whole focus is on making Windows platform more and more secure, right? So, and our vision with this technology is that going forward, we see these applications which opt into Win32 app isolation or security primitives like that are going to be considered as the best citizens on Windows, right? Which means there are some apps which are probably left behind or they do not onboard themselves to these latest and greatest standards of security and privacy on Windows. they may not be considered as the best citizens of Windows going forward, right? And I don't know the timeline, but that's a direction which we want to take. So sooner or later, you may start even seeing those visuals which differentiate between these two kind of citizens on Windows, and then the operating system will handle those applications accordingly, right? So you may see things getting more constrained, where these applications who are left behind, they are, in terms of the reputation of those applications, they may not come out to be 100% green, things like that, right? So we, like Sumit was mentioning, we launched the Smart App Controls, which is nothing but a reputation-based fingerprinting of the applications. These results may feed into that, and that may start differentiating the apps which are left behind with the apps who have onboarded themselves with these latest and greatest privacy and security primitives. And that's the vision. Timeline, I don't know, but probably that's going to happen sometime in future. And Rohit is there from privacy perspective. Rohit, if there is anything there from the privacy part of it, if you want to add anything there.
Hey guys, can you hear me?
Mute.
Can you hear me?
Yeah.
Hello?
Loud and clear.
Yeah, thank you. I'll just plus one to what Abhijat said as well. I think what we want developers to think about is we are providing Windows as a platform is providing you these capabilities for you to kind of get your applications running in a more secure environment that allows more choice for customers. And like Abhijat said, our projected North Star is that we have all these apps, or as many apps as we can, run in these secure containers. And I'll also throw this one other aspect, right? So not only from a platform perspective, but developers should also start thinking about all the different types of regulation that are coming on, that are out there, right? So this isolating, putting your apps into these containers will give you additional capabilities as well, and you can say, okay, if I am running in a secure environment, or I am running in let's say in a government, let's say you're running in certain geographical boundaries, it'll also give some additional capabilities that you may not get by just having it run natively on the platform. So as the future technology, I think this is the way we would like all applications run. And like Abhijat said, we have some ideas about how we would like to differentiate these apps. And then it's also going to be all goodness from a consumer standpoint as well. So we really encourage you to think about adopting this technology, test it out, give us feedback. And then, hopefully we can partner together to kind of build a more secure and, privacy-aware app.
Great. Thanks for chiming in, Rohit. And I think we have room for just one last question, and I can see that pop up into the chat. So John is asking, what is the difference between this technology and existing partial trust Win32 applications that are possible with MSIX packaging?
Okay, so the difference is between this and the existing partial trust is the partial trust is really just an app container. Running an app container, it doesn't have the visualization, it doesn't have the brokering, so you're limited. You'd have to use things like Win32, WinRT APIs and things like that if you actually wanted to have access to files outside of the application's directories. So yeah, the partial trust today is more limited. What we've done with this work is to try and make it that with as much as possible, with minimal modification or no modification, Win32 apps work seamlessly without losing any functionality. And you won't get that with partial trust.
Great, thanks, Salah. So with that, I think I would like to wrap up the session now. And there is a link to the feedback. That's very important for us. So please click on that and give us a feedback. Thank you very much for joining today, and you have a great evening.
Thank you.